Air that enters the nose is filtered, moistened, and warmed by structures in the respiratory mucosa. Coarse hairs filter out large dust particles. Seromucous glands secrete antimicrobial substances and mucus that traps and moistens the air. Blood flowing through capillaries in the mucosa warms.
Sufficient indoor air humidity is crucially important. The mucous membranes in the nose and the lower respiratory system feature innumerable tiny hairs, cilia, on their surfaces, which move like little whips in a watery saline layer. Cilia are covered with a sticky, gel-like mucus layer that traps pathogens and airborne pollutants. The movement of the cilia transports the mucus to the larynx, where, together with its cargo of pathogens, it can be swallowed or coughed up, and thus rendered harmless. As relative humidity drops, however, the saline and gel layers start to dry out. Volume and thickness of the layers shrink, and the cilia are progressively pressed down until ultimately they can no longer move at all. As a result, the pathogen clearing process comes to a stop. Accordingly, viruses now find it easier to penetrate cells and cause infection. Experiments have shown that the fastest transportation of pathogens, and thus the lowest risk of infection, is achieved at levels above 45% relative humidity. As humidity drops below this value, the cilia find it increasingly harder to move, and the risk of infection